Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome everyone to the mini-series Next Generation Energy Leaders of the podcast Insider's Guide to Energy. My name is Luca.
And I'm Jill, and we're your hosts for today. And in today's episode, our guest is Marius from Nexus-e. He's the project manager of this integrated energy systems modeling platform. And I'm really excited to talk to him about what this platform is actually doing and about his task also as a project manager.
Yes, it'll be interesting. I've done a little bit of energy modeling in my master thesis, but nowhere near as complicated as this sounds. So yeah, I'm looking forward to hearing what he has to say.
Yeah.
Indeed. Very interesting episode. So without further ado, hi Marius, it's a pleasure to have you with us today.
Hi, thanks. Thanks for having me, and looking forward.
All right, I'd say we get started. Marius, could you briefly introduce yourself and also Nexus-e to the audience?
Sure. So I'm like a mechanical engineering engineer per training. So in my bachelor's and master's, I studied a mix of mechanical engineering, business administration, and economics back then in Germany, the IWTH, and then for my master thesis, I came to ETH and then stayed there for my PhD and then also for Nexus-e at the Energy Science Center. And I'm doing the project management for this platform, and at the same time, I'm also doing my own research as a postdoc. And yeah, Nexus-e, I think you already said a few of the buzzwords of the platform. So it's like energy system optimization modeling platform. So it's a long word and it sounds quite complicated, but short, it's a platform, and you can add your own energy system model to it, and it already has quite some models on it, and these models can communicate with each other so that each of the modules only has to represent a part of the energy system. So for example, if one researcher is developing only a subsection of the energy system, the person can add it to the platform and make use of the other models that maybe represent another part of the energy system. So I think that's quite powerful, and it saves a lot of effort for the researcher that already can leverage the existing models that are on the platform.
Yeah, that sounds already very fascinating, and I'm looking forward to going to more detail. Maybe just stepping back a bit. You said you're a mechanical engineer by training. What did you do during your PhD in Zurich, and how did that whole process from going from the PhD to this project management at Nexus-e, how did that go about?
Sure. So I did my PhD at the group from Professor Volker Hoffmann, and the group is called SUSTEC, so Sustainability and Technology. And actually, we do quite a lot of different stuff at the group. So it's not only energy topics and it's not only engineering. So it's a mix of, it can be finance, it can be engineering as well, of course, but also politics. So it's quite an interdisciplinary group or mix of people, and also management and economics. And the idea is to focus on the intersection of what is sustainable and what can technologies do to make the world more sustainable. And in my PhD, I also did quite different things. So also from the methodologies, I did expert interviews, but I also did some modeling. And for the modeling part, which is maybe more interesting for this talk, it was about evaluating different policies on their effectiveness to accelerate the uptake of renewable energies and especially solar photovoltaics. And I did it for California, but also for Switzerland. Yeah, and it's like more or less like different versions of subsidies. For example, I think right now the topic is again quite hot here in Switzerland because the numbers of renewables or of PV or solar photovoltaics is too small. So there are discussions on how we can accelerate it again or how we can bring in more PV into the market. And then you of course have to discuss policies. So should there be more subsidies for PV, or is it already too many? And what would be the costs of such subsidies? And then I think you're also asking about the transition then to Nexus-e. Yeah, that was pure coincidence, I would say. So I was still doing my PhD, and as I said, I was doing some modeling work, but also not near as complicated or complex as Nexus-e. And I was like, I created my own model, and it was disconnected from every other model, and it was like my my small model. But then just my professor Volker Hoffmann just told me about this open position at Nexus-e and doing the project management, and I am trusting him very much. So I thought, okay, if he suggests me this position, he's probably knows that it would be a good fit for me. Yeah, in the end, I think it was, or it is still a good fit. But as I said, it was nothing like really planned long ahead. It was more short term. Yeah, and I switched during my PhD already to Nexus-e. So I finished in December 2019, and I already joined. No, 2020. No, December 2019. No, 2020.
So with
2020. Sorry.
with COVID.
Yeah,
Oh, okay.
yeah, there was already no COVID just started when I was exactly. I finished with COVID, and I just started at the Energy Science Center at Nexus-e when COVID started. Yeah, I had such a
Okay.
long time already ago.
Yeah, yeah. That I mean, this is really valuable. Looking at the audience or who we are targeting basically is people like you and us. You being a bit further than us already, but people who want to know what it's like to have this transition and that it is most of the time just a lucky coincidence.
Yeah, and I think also a bit like knowing maybe who's your mentor, who you can trust, and also then be open to these people, what you want to do, what you like to do. Yeah, and just talk and be open to these people.
Something we actually try to ask every podcast guest is, what are your recommendations for fellow graduates making like the first steps after their studies?
Yeah, it's always a tough question because I mean it's for everybody it's different, right? So I mean I was quite lucky, I would say, with that I didn't have to apply somewhere after my studies, or it was just like a smooth transition since for a long time. So I think that was quite nice for me. But in the end, I would also say that I just went there where it was comfortable or where I felt comfortable with. And I mean, I was also letting myself guide it a bit with where not only the job which I like or I feel good with, but also the place and the people around me. So, and for example, I really like to stay in Zurich. So everything else was not every like other job position that might have been super nice and like a great fit. I was not really into it because I like to stay here. So I think that's for me very important that even though the job can sound amazing, if you are then not comfortable in the situation of being in another place, of missing people that you want to have around, then it's maybe not the best choice. But yeah, that's I think really personal and it's not really job related.
Yes. But do you, so talking about the people you work with at Nexus-e, how many people are there in this whole project? And as I understood, and we'll be talking about the architecture later on, who are you involved with? What are these people only working on Nexus-e, or are they just partially working on Nexus-e? How does that work?
Yeah, sure. So the um, the the heads or the leaders of
Yeah.
Nexus-e, they're like the professors, right? And there, I think right
Okay.
now, 5 professors actively involved in Nexus-e, and there can be from electrical engineering to mechanical engineering, or more like policies or economics. So that can, it's always depending. Sometimes we lose a professor because they go to another university, for example, and then we get new professors. Then maybe it's professors that are new to ETH and are interested in on the one hand in Nexus-e as a model, and but also in a bit of the network. So yeah, so it's the professors, like around 5, and then the professors, of course, they have their research groups, and usually 1 or 2 researchers per professor join Nexus-e. So I think it's mostly
Okay.
1, but sometimes it's 2. And so that's then the researchers, and they develop the models further. Usually they're focusing on one model, and try to make novel academic contributions. And then because that's of course required for doing a PhD or postdoc work. And then on top or below that, however you want to see it, then we have people that work on the infrastructure. That's, for example, a person that develops our web viewer for the results or updates the database that we have. So it's kind of the infrastructure that all modules use. And I think that's quite nice that we do this work so that the research can really actually focus on the module and and trying to build up something novel, and not everybody is wasting, or not wasting time, but spending time on collecting the same data. So I think that's quite helpful. And then of course you also have my position as project management, and and maybe a bit of outreach of Nexus-e.
Um, I'm going to go ahead and ask the next question if that's okay. So let's talk about Nexus-e in not yet the modules, but more like what problems are we facing? And as I heard, the focus is mainly on Switzerland and the energy system of Switzerland. What problems, for people unaware of this, what problems are we facing in Switzerland? And how does Nexus-e help to solve these problems?
Maybe you could give us a quick insight on how the project even came about, like the beginnings of
Yeah,
Nexus-e.
sure. Yeah, I think
Yeah,
it's very related. So maybe I can go a bit back and tell us a bit
yeah,
how it started and which problems or topics Nexus-e was focusing back then, and maybe then how it evolves a bit. But maybe if I lose the bigger question, then remind me of it. So uh,
all good.
so I think I mean, I was not in Nexus-e back then from the start on. So as I said, I just joined 2 years ago, so it's a bit before my time. But as the rumors were saying, there was this or the Fukushima thing happened in 2011, and based on this, like nuclear power was discussed. I think in most industrialized countries, whether they should get out or phase out nuclear power or not. And we also had the discussion in Switzerland, and and then it was like a societal discussion, but also political discussion, and ETH, of course, tried to contribute to it. And there were a lot of studies on this, but there was kind of a missing piece, because there were some studies that evaluated the technical feasibility of the phase out of nuclear power for Switzerland, and maybe then there were also some economic studies on this. What would it mean for Switzerland from a macroeconomic perspective? But there was not a joint study that tried to harmonize both perspectives and the assumptions of both perspectives, and then do like this comprehensive evaluation of what the nuclear phase out in Switzerland would mean. And that was the idea when Nexus-e was founded or started. That was then already in 2014, 2015, and so this was kind of the first topic that Nexus-e wanted to focus on. And then it was the idea of bringing together this engineering, techno-economic perspective and this macroeconomic perspective. And to do that, they created like a conceptual module or plan for Nexus-e, and this was when the idea of these 5 core modules of Nexus-e was born. So that you have a module for or 2 modules for the power generation technologies, the investment and the dispatch, or mainly the investment in power generation technologies and storage. Sorry. Then there's one module on the market and how are these technology being dispatched to meet or to cover the electricity demand. Then there's another module that focuses on the electricity on the transmission grid. So the transmission grid. So can the grid actually handle all these power flows that occur from meeting the demand with power generation technologies? And then finally, the macroeconomic module, which evaluated the impact of these investments on the Swiss society. Yeah, so that was then the foundation and the development of these models and their interconnection, their communication, to embed them in an infrastructure so that they all use the same database, for example. That was actually finished just when I joined Nexus-e, so in 2020. We had there was the product finalization together with the Federal Office of Energy. So I was involved in developing the final presentation when I just started in finalizing the reports. So that was actually a good start. And since then, I think a lot of things changed. So back then, in the beginning, it was a focus on the electricity system, or the large part was focusing on the electricity system. And now we are continuously moving to have a broader view on the entire energy system. We're going a bit away from only using these 5 core modules, but we are trying to find, or we are using substitutes for different of these core modules. We are adding new modules to the system. And that's the current focus. And of course,
Very cool. Very, very interesting. So is the quick question in between, is the intellectual property of these modules, is that with the professor basically, or with the research group? And if he leaves, he can basically take the module with him? Or is the module part of Nexus-e and that stays and is transferred to the new professor in that case? What happens?
Yeah, I mean that's always that's a good question, and I think it's also one of the biggest challenges in Nexus-e. So our our goal is to make Nexus-e open source. So I think we already have prepared everything to make the models open source. So it's just some last fine tuning. So I guess in the autumn this year, Nexus-e will be fully open source when it comes to the model. But the bigger question is how to make the data open source. And without the data, it's very hard to use the model. So if another person wants to use Nexus-e and has not our breadth of data, it's very difficult. So we also have to make this, or to enable somehow the open data. But and as soon as the models are open source, then you don't have this issue anymore of whom does one model belong to, right? So because it's open source, everybody can use it. But of course, you have so much tacit knowledge in developing these models. So yeah, so it always takes some time if a new researcher wants to use an existing model and then develop it further compared to the person that has already developed the model.
So is there a specific party or maybe customer that brings ideas of what you're going to model, of what the system should look like, or for whom are you bringing up those results?
Yeah, I mean, now you could get philosophical because it's academic work, so you're trying to make, of course, the work for the society. But in the end, it also comes a bit down from where we get funding. So we all kind of need to get our salaries, and most of the funding we get from the Swiss Federal Office of Energy, and there it's project related. So they just had this quite large funding scheme suite, and Nexus-e is part of two of the groups, or not groups, consortia that got how to say, the okay or the approval for this for the funding, and these projects are now for the next 5-6 years, and Nexus-e is, as I said, part of two of them. So these projects have a defined topic, right?
Okay.
So Nexus-e is also being developed to to do the assessments that we promised in these projects.
So that's I find that very interesting, and I would like to quickly dive deeper. That do you know, or can you already tell a bit what these topics are of these consortia, or is that disclosed information?
No, it's not disclosed at all, and it can all be found on the website. But so that we are in the two consortia. The one is called Sweet Pathfinder, and the other one is called Sweet Edge. And in Sweet Pathfinder is about developing scenarios for the Swiss energy system, and with a particular focus on the sector coupling and flexibility. So, for example, what is the flexibility that the transport sector can offer due to its electrification? That would be, for example, one classic or one well-known sector coupling discussion. But the same with the heat and heat pumps, right? So with the electrification of some sectors, the sector coupling part becomes stronger. And then flexibility, yeah, I think that's a very broad term, but everything that I don't know actually how to explain flexibility. It's super broad. Maybe
It is.
we can cut this out. Yeah.
Yeah, no worries.
And the other project is Sweet Edge, and there the focus is also on scenarios. I mean, of course, because Nexus-e is developing scenarios, but there it's really about the diversity and the heterogeneity in Switzerland. And the topic is that the idea is to develop scenarios for urban parts of Switzerland, for the Midlands, and for the Alps, and how the pathways or the energy system for these different parts of Switzerland are different.
Okay.
Maybe a more in-depth question on this. You mentioned sector coupling and flexibility, and before you said you do have a model, or you look at a module based on the transmission system or the transmission grids. Do you also consider distribution grid, or is it something that is left out at the moment, or how? Like, what kind of levels are you looking at the moment?
Yeah, I think that's a very good question. So, as I mentioned before, I think it was also in the beginning you always had this very high level system perspective. So you were only looking at the national level or at the very low level, mostly on the building level, but everything in between was left out. So, and even in the beginning, when you were looking at the national level, sometimes you were not considering the transmission grid level at all. So you were just thinking about it as a copper plate. So electricity could flow from could flow anywhere without any restrictions. And then the next step was to consider the transmission grid. But I think it's a very valid question, because when we create these scenarios, and in our scenarios we say, okay, in these scenarios you see 40 terawatt hours of solar PV. I mean, what we can now assess is, can the transmission system handle the power generation from these 40 terawatt hours of PV? But we have no clue whether the distribution grids can actually handle that. So I think that's a very valid point, and a very valid question. And currently we are also working on integrating a distribution grid model in Nexus-e. And the key challenge there is it's data availability. So it's very hard to get data from distribution grid operators. And of course, you will never be able to collect data from all distribution grids, because it's quite a lot. And then it's a bit the question, maybe you get 5 or you maybe get 10 of the distribution grid data, but how do you scale it up? So how can you make assessment? How can you make generalizations based on a few case studies for entire Switzerland? And we are currently working on a methodology on how to make this possible, that you work with, how do you say it? I'm lacking the word right now, but it's kind of representative grids. So you have some archetype distribution grids, and you assess these archetype distribution grids, and then you, with another methodology, around about how many of these different archetype grids there are in Switzerland, and that's kind of the way how to scale it up. But I cannot explain it right now better.
All right, interesting. And for the scenarios, what else do you consider at the moment?
So as I mentioned, so one of the current goals is to get more people working, or more researchers working on Nexus-e. And that was one example with the distribution grid. Another example would be, also as I mentioned before, to make Nexus-e covering the entire energy system. Another example is that we want to make statements on the life cycle assessment. So what are the actual carbon emissions that are the result of all the investments into different infrastructures? I think that's more or less the range of our projects right now.
I think it shortly kicked me out. Is that correct? Did you
Well, we
realize?
didn't see your.
Yeah. Well,
Yeah.
good. But I just quickly want to, when we talked about the distribution grid, I thought, what about the large scale? What about international environment? To what extent do you guys integrate also the developments that is happening in our neighboring countries?
Yeah, I think that's also very relevant and very valid to have a question on this. So how we do it within Nexus-e itself is that we represent the neighboring countries, but also in a very aggregated form. So, and we do not optimize the number of generators in the neighboring countries as we do it in Switzerland. So we take scenarios, for example, from NCOE, from the Transmission Grid Operator Association or organization. So we take scenarios from them for the neighboring countries, and then include them in Nexus-e. So we have some knowledge about their demand and supply, but with a strong focus on Nexus-e. But what we do besides that is we link kind of the detailed or Nexus-e, which has a detailed perspective on Switzerland, with, for example, Europe Calliope, which is a broader energy system model, which covers entire Europe, but every country on an aggregated level. And by this, we can, for example, first optimize the entire European energy system, and then use the results from this model as boundary conditions for Switzerland. So we have some kind of we
Okay.
have some data or we get some results on also the neighboring countries. Yeah, and then we can make use of that in Nexus-e.
Okay, very interesting. Just a small side question. Calliope, I've a friend of mine did his master thesis with Stefan Pfenninger. Is he the one doing that? Is
Yeah,
that correct?
exactly. So he was the
Okay.
I think the original developer of Calliope, but it's also open source,
Okay.
and there are kind of two
Mhm.
versions now. The one is Calliope, and the other one is Europe Calliope, and is now
Okay.
being used by quite some groups. So it's still used at ETH, but Stefan Pfenninger moved to TU Delft, and
Oh, okay.
it's also used there. So I think it
Okay.
is
Nice.
very successful and good tool.
Mhm.
But I think
Um,
it has a bit of a different approach. So for example, with Calliope, it is more about this one model that is
mhm.
continuously being developed. And with Nexus-e, we have this kind of platform thinking, right? So you
Mhm. Mhm.
can develop part of
Mhm.
the system and then connect it to the other modules.
Mhm.
Whether this is the better approach or the worse approach, I don't know
Mhm.
actually, but I think it's both interesting.
Mhm.
Can you already give us an insight on the biggest findings of those energy systems modeled?
Yeah, do you mean findings in terms of the scenarios or findings in terms of collaboration and
In terms of
in
scenarios.
terms of scenarios? That's always tough because um,
I reckon that's a lot
y-
of models you
yeah,
did.
no, I think one of the biggest findings is that um, right now, for example, there is a lot of talk about hydrogen being required as an electricity store or like a storage. So it's
Mhm.
that you use electricity to generate hydrogen, and then you use hydrogen again to create or to generate electricity. And in our models, we just don't see that it's getting built in Switzerland. Uh, and we were surprised also in the beginning, but it's just not economically feasible, at least under our
Mhm.
assumptions. And
Mhm.
it's and that Switzerland has enough, or what means enough, but with imports and the flexibility provided by hydropower, it doesn't need
Mhm.
hydrogen as a storage, at least under our assumptions. I don't want to say that it will not be required at all until 2050 in Switzerland, but at least in our scenarios,
Yeah.
it is not getting built. And I thought because the topic is so hot, as soon as we integrate it in
Mhm.
our model as well, there will be only hydrogen. I mean, I'm exaggerating now, but there will be some hydrogen,
Mhm.
and actually,
Mhm.
it's not getting built. So I
But
oh,
would you say there is no actual need for storage apart from hydropower or pumped hydro systems, or is it just because of the hydrogen probably too expensive in relation to the efficiency, or what's the main problem
yeah,
there?
so I think it depends on. Okay, so you have. I mean, usually I would for Switzerland I would see two different use of storage, right? The first use is for hourly and daily fluctuations, and I think for this variability or fluctuations in the system, I think Switzerland is very well prepared. So we have hydropower, pumped storage. I think using electric vehicles in the near future for addressing or to have some demand shifting, I think that's
Mhm.
all very likely to come. So I don't see an issue for these hourly and daily fluctuations. The bigger
Mhm.
problem in Switzerland is it's always about the winter. So there's a lack of electricity in winter. So seasonal storage and hydrogen could act as a seasonal storage is on the first glance, it's very useful because you have too much electricity in summer, you can store it, or you can produce hydrogen, then store it, and then make use of it in the winter. But in our scenarios, it is cheaper to import electricity than to build up
Mm.
the entire infrastructure for hydrogen generation and storage.
Mhm.
Of course, there are uncertainties about whether Switzerland can import that much as we see in our scenarios, or whether there will be lack of winter also in the neighboring countries. Sorry, lack of electricity in winter in the neighboring countries. So that has higher uncertainties, and therefore I wouldn't say that it's for sure not needed. And it's of course a valid technology that might help Switzerland to reduce import dependency in winter. But it's right now it's comes with higher costs than still importing.
Yeah, that is. I think that's really, really fascinating, and I think what it shows is that the next project. So this might have a cascading effect on Europe, right? What happens to Europe when the imports of Switzerland need to be increased because we don't have hydrogen? So the next project would be making a Nexus-e of whole of Europe, right?
I I think we I think I think it's better to avoid developing a new European model and make use of the existing ones.
Yeah.
So I would rather
Yes.
I would be happier to extend our collaborations with other European models than developing one our own.
Yeah. Very cool. Yeah, that's fascinating.
But I guess that means you could show that, especially in winter, Switzerland is dependent on its neighboring countries.
Sure. Yes, it is. I mean, it is already today. I think there's
But
no
we're
doubt about that. Yeah.
and it's not, I would say, economically feasible that we change that Switzerland is independent.
Yeah. I mean, I think it's. I mean, I would say autarky is never a state that you want to achieve. I think it always is highly inefficient and comes with the highest cost. But of course, you want to have the dependencies not too high, so that you're not kind of getting politically unstable, or that you can, yeah, for example, then the EU connects electricity agreements with other bilateral agreements or contracts. So I think that's not a state that you want, a status that you want to have. But yeah, so some imports are fully fine, and Switzerland's also exporting in summer. And I think last year Switzerland made a slight minus in the trade balance, but the year before was a plus. So I think it's always slightly around zero. So I think it's all fine.
Yes.
But the winter imports shouldn't get too high, and in our scenarios they are quite high, to be honest. So if Switzerland wants to reduce it, there are some ways of addressing this, and one would be seasonal storage, but with high costs. Other alternatives would be trying to reduce demand in winter, and other alternatives would be to increase electricity generation in winter. And we just had, for example, an article on solar PV in the Alps, because they produce like more or less half of their electricity in the wintertime. So that could be at least an interesting technology, but it has some acceptance and regulatory hurdles, and also it also comes with higher costs. Yeah, but I think it's an interesting technology.
Yeah. We're slowly coming to the end. Jill, do you have any final questions to ask?
I do actually, I do. What do you see in the future for Nexus-e?
Yeah, I think I mentioned a couple of things already. So I think for me, getting open source is very important, so that it's also that more researchers can actually work on it, and that we also streamline the process of a new person joining Nexus-e or just using Nexus-e. So that right now it is some effort to get started with the model. So I think that is kind of key to me, that we improve that. Yeah, and the long term is a bit like this. Okay, that it's becomes kind of as a standard model or modeling platform that is being used for creating scenarios. So, for example, if the Swiss Federal Office of Energy the next time wants to create their energy perspectives 2060 plus plus. I don't know. That they
Small inside joke.
yeah,
there.
that we are. I mean, they okay. Maybe to get it back a bit. So the Swiss Federal Office of Energy always develops. I think every 5 years, in steps of 5 years, new scenarios for the future of the Swiss energy system. And of course, it would be great to leverage Nexus-e and their work at ETH to create these scenarios for the Swiss Federal Office of Energy. So that would be the future that I hope for Nexus-e.
I might ask a last question. On a personal note, one thing we also ask all our guests is, judging or looking at your daily work, what is it that that fulfills you or really motivates you, and what parts of your work do you really enjoy on a day-to-day basis?
Yeah, I think the first is, I mean, it's the topic itself. So I think, I mean, I'm working on the topic since 2009. So it's now 13 years. So it's quite a bit, quite a long time. So it is a topic that is fascinating to me, and then that the work we are doing with Nexus-e is also relevant on this topic. So I think we can create some scenarios or create some insights that is interesting for policymakers, for the ministries, and maybe also for the society to know. Of course, that that's maybe too much, but maybe it has some influence. So at least that's my hope for it, and I think that's also what drives me a bit. And then also so that's more relating the topic, but then of course also the work style that I currently have. So it's I'm quite flexible with which projects I'm following up, which like topic within the energy topic we're trying to cover next. So is it alpine PV? Is it now hydrogen? Is it, I don't know, trying to make clear why nuclear extension is not a good idea for Switzerland. So we can follow up on a lot of discussions, and I think the flexibility on choosing which one we want to do and which we think is interesting, I think that's very fulfilling.
Yeah.
Yeah,
Cool.
definitely a lot of interesting topics you're working on there. And it has been a really interesting talk. We're really happy that you were with us today, and it was a pleasure hosting you.
Thank you so much for having me, and it was fun.
Yeah, very insightful. I'm looking forward to seeing Nexus-e becoming open source and all other things that we are looking forward to in the future. And for listeners, thank you so much for joining us, and remember to like and subscribe to our show. We're looking forward to talking to you soon. Goodbye.